profession. Today, we are so lucky to have with us Miss Alexis Norris, who is I'm going to mess this up like 15 times today. She is a bioinformatician. I think I said it right.
Perfect.
Thank you for the FDA. And she's going to spend some time with us today, just talking a little bit about her career journey and how she got here. And so I'm going to give her a chance to kind of introduce herself, and we're going to go ahead and get started. So, Alexis, thank you for joining us. We're so honored to have you today. So, tell us a little bit about yourself and, kind of what, the backstory to you.
Well, first, thank you for inviting me to this. I got involved with MBRT and going out as a STEM specialist in grad school, and it was such a great experience. And all of the best interns I ever had were high schoolers that I met across the state. So I benefited a lot through MBRT, and I really enjoy it. And thank you for the invitation to talk today. So my current role is as a bioinformatician at the FDA. But today I'm speaking purely representative of myself. So any opinions or statements are mine alone and do not represent any opinions of the FDA.
Perfect. Understood. So you are speaking for Alexis, which is what we absolutely want today. Thank you so much. So I said it already from the beginning that I am going to screw your title up probably royally, so I apologize from the beginning. But tell us exactly what is a bioinformatician, if I said it right.
Yeah, so a bioinformatician is basically telling a computer how to do a biology experiment for you so that it does all the boring work and you get the exciting results at the end, which allow you to learn something about biology. So I guess in your typical biology lab, you're doing work at the bench during lab, and I learned how to write. I learned a computer language. It's the same as learning Spanish or any other foreign language, except you don't have to worry about pronunciation. You just have to worry about grammar. So that's a bonus. And you just learn this language, and you write instructions for a computer to do the experiment for you. And the best part is that you don't have to be at a you can be on a beach, you can be at your house, you can be snuggling with your dogs. And so that's what appealed to me. And also I was okay at the bench, but it wasn't really that great. And so at the bench, you might spend, a week or two on an experiment. And if you make one mistake, you have to redo the whole thing. And in bioinformatics, if you make a mistake, you just fix your typo in the instructions you wrote. You just fix your grammar and press enter, and it goes again. And there, you don't have to buy more reagents. You don't have to reset up your entire experiment. So that room for error and for toying around with experiments and not really suffering any consequences if it doesn't work correctly, because you can tweak it and try again. So that's what I feel.
That is like so interesting. I've never heard of anything like that. So I've got like a gazillion questions now because of that. So I guess the first thing is, given, the way the world is right now with everyone at the stay-at-home mandates and the self-quarantining, because it sounds like it's kind of like a hybrid between a biologist and an IT type person or someone that's into computers. So given the way things are right now, how has this situation affected the way that you work in your position? Or, because I'm the way I'm imagining is that, even though you're doing, I guess, inputting everything in the computer, but I would think that at some point you would need to have like a lab or like a bench, you said, somewhere in your home. Has this impacted the way you work at all?
So I'm very fortunate in that all of my work is always done on a computer. And so working at home on a computer is something I'm very used to. It's something I've done since I've started being a bioinformatician. And so my work is not really impacted. All I need is a computer and internet, and I can do bioinformatics. So I'm very fortunate, and it's definitely a reason to pursue bioinformatics, is that there is job stability. There is the ability to work from anywhere. So it gives you a lot of freedom in your career.
Awesome. So, okay, now I guess that leads to the next set of questions that I have. Is this something that you've always been interested in? Were you in high school? Were you the kid that loved doing experiments in chemistry or in biology? And for someone that maybe is interested in biology, is this something that they would pursue? Or is this more so someone that is maybe more computer or tech savvy or into, IT type things, but maybe not so much into the science part of it? Or do you have to, I guess, be interested in both?
So I did not learn to program until I was 27. So you don't need to have a computer background. That's something you can learn. There's generally two types of bioinformaticians. There are people that come from a computational background. So they, maybe major in computer science or statistics, and they learn enough biology to write computer programs to solve biological problems. And then there are people like me who really just care about biology, and for me that's genetics and DNA. And along during high school or during college or graduate school, you realize, hey, all this work I'm doing, I could do much faster and much easier with a computer. And so then you pick up a computer language, just how if you minored in, French, it's the same thing. So it doesn't have to be a major skill you have. It's more of a lab technique that you learn, just like you would any other lab technique, to do a biological experiment. So I'm not a computer expert. What I do is I use programs that true computational experts who do training and statistics and computation that they write, and I just use those and basically write a few sentences to tell my computer how to run that computer program. And so it's basically glorified Excel. If you can write an Excel function, you can learn to code enough to be a bioinformatician. You're just using a computer to do the experiment for you.
And you said a word that I hear coming up in education so frequently now, especially even with younger kids, and that's coding. I know that there's camps, and I see even a couple of businesses that have popped up that, is centered around coding. So that I see a couple of questions coming in on our live feed, and it was actually the question I was just about to ask you. How did you decide, or when did you decide that this was something that you wanted to do? Or like when you first went to college, did you know this is what I want to study and are majoring, or did you kind of just fall into it as you started taking your studies in college?
So in college, I focused on genetics, and I mean, to be honest, I really don't. The only thing in biology that really interests me is the DNA and how it makes us, how it causes disease, how we can study it to create therapies, and so that's what really interests me. So I got through the plant and animal sciences, and I love animals, but I never thought of myself being out in the field doing ecology experiments. So, but then at the end of college, I realized that PhDs, which is graduate school, they aren't just for professors. They're also for scientists that want freedom over what they research and are really interested in focusing on a specific area. And so obviously I cared about DNA, and I wanted to learn how to look at DNA. And so I was considering a master's or a PhD. A master's is a year or two, a PhD is 4 or 5 years. A master's you pay for usually. A PhD in biology you get paid for. Wow. And you're picking your classes, you're picking what you study, what you research, and that was really attractive to me. And so I went in studying genetics of cancer, so looking for cancer genes. And a year in, I got data from studying the entire DNA sequence in cancer patients. And I tried to load it into Excel, and it sort of worked. And I had to make a change, like add a column. Mm-hmm. And I spent almost a month adding one column because it was tens of thousands of rows. And of course I made mistakes because I'm doing this by hand.
Right.
I wasn't a pro at Excel. I didn't know how to do macros or anything. And so it reached a point where I'd spent so much time and it was so boring and so tedious. And it was so painful going through what errors I made. And then a friend mentioned, because they knew a little bit of coding, and they said, hey, you could do that in one sentence.
Oh, wow.
That blew my mind. I was like, well, I don't know. Like, I don't code. I'm really, I know how to use Facebook, but I don't call myself like a computer wizard at all. I don't build computers. I don't know how to write computer programs. But they gave me that sentence, and it ran in 5 minutes, no errors.
Wow.
And so I realized that it was worth spending a little bit of time learning how to write these sentences rather than doing really boring work. I could have the computer do that boring work for me, and I could do the fun stuff, like look at the DNA and find the genes instead of fighting with Excel.
It also sounds, like that's like mind blowing to me. I'm sitting here like kind of going, psh. And it almost sounds like, from, if I'm hearing you correctly, that by being able to use the coding and doing that one sentence, that even your efficiency rate and the amount of time that you're able, or your productivity actually increases, because instead of spending a month doing something, you're able to do it in 5 minutes, which allows you to get more done, it seems like.
Exactly.
Wow.
And you're doing the fun stuff. You're not doing the boring stuff.
So I've heard you say it a couple of times that you're really interested in the genetics and DNA. So in terms of being a bioinformatician, yeah, I got it. So thank you. Are there different, I guess, like areas of the position that you can do, or is everyone always focused on like DNA and genetics, or how do you like decipher or determine what area you want to go into?
So bioinformatics is just using a computer to do a biology experiment. So that could be anything. That could be studying plants and animals. That could be looking at microbes. That could be forensics. It's like ancestry, the way that you spit in a tube and you send it off and they tell you, your ancestry breakdown. It is a bioinformatician who does that analysis. It's a lab tech who processes the sample and gets the data, but decides, percentage you are. That is a computer program that a bioinformatician is doing. So any biology experiment, if you want to analyze it, you can get a computer to do it. You can do it much quicker and much easier. And then you get to spend your time, which is what you really care about, looking at the results and interpreting them and saying, what does this mean? And the side benefit, my interest in DNA was, I was obsessed with knowing, how does DNA make me, and how does it make you? And because I have these skills as a bioinformatician, which is, something I learned through training in school, as the added benefit of I can study my own genome. I can study my dog's genome. And so, that's something I do in my free time, just, looking at it. And it's just really empowering to be able to see your own DNA, and just so exciting. What's cooler than seeing your own DNA?
Absolutely. I'm sitting here and I'm like listening as you were talking, and I'm thinking about like our student base and the students that we serve. And, for those that are watching this and that kind of go, hey, that sounds pretty cool, but, how can I, get into this? So I guess if I'm hearing you correctly, so bioinformatics.
Correct.
Okay, so that can span across basically any industry, really, if I'm understanding that. So to the person that's thinking, oh, I have to be into genetics or plants or something, that doesn't seem like that's the case. You can really apply this type of position and these skills to pretty much anything that has research or data associated with it, it seems like. Is that a fair assessment?
No, that's true. Yeah.
Awesome. So why would a student want to consider this profession over the traditional research scientist or a biologist?
Yeah. So if you like the idea of being able to work from home, you like the idea of starting out, after a master's or a PhD at over $50 an hour. If you like the idea of, having geographical restrictions removed, so that you can telework. I mean, you can work remotely. So if you want to go to a cabin in the woods, if you want to go to the beach, you can still do work. If you like that, the idea of being able to fail at experiments, and that's okay, and you're not set back forever. You don't have to love computer coding. You
Okay.
just have to love getting to answers in a quicker or better way. So if you love anything, in biology, and it's not even biology. I mean, they can use computers to analyze, physics and math and, chemistry, anything, anything where you're creating a lot of data, which is almost anything nowadays. We're using computers to analyze that data because it's much quicker, and no one likes to do that tedious work. If you like to be at the bench, there's also, you can do hands-on experiments and analyze the data. There's a lot of people that do both. I just really realized that my strengths were not at the lab bench, and I really just enjoyed, the flexibility of using a computer to do the boring stuff.
Okay. Well, I mean, that's fair enough. I mean, and this kind of goes, I guess, to my next question, which also kind of deals with kind of what we're all experiencing right now. So many people are finding themselves teleworking right now. We know our students are having to experience online and distance learning, a lot of them for the first time. So a lot of the things that I've heard a lot of our students say, and even my own daughter, they're experiencing that separation anxiety from their friends and from their teachers and from the physical building. And it sounds like this position is a position where you probably don't have a lot of interaction with other people because you're pretty much teleworking. What does a typical day look like for you?
So, so one advantage is when I am in person, it's usually talking biology. Like I still do that. I still, when I spend most of my in-person time when I go to conferences or go to codeathons, and so most of my in-person interactions are really exciting. And then the coding community, we lean on each other to learn what people are doing, to help us find the typos in our code. So it's not alone. It's just an introvert's paradise where you're connected to people, but it's in a digital way. And it's definitely made it a lot easier to transition, to this kind of or unfortunately, because I'm kind of used to this, being able to work from home, and still maintaining that professional network. And it's just such a really rich community, and bioinformaticians, that's how I operate. All the good papers I find out on Twitter. Like that's where I find out what I'm gonna, all the newest, hottest tools. And so I still have that connectedness. And if you're an extrovert, it's probably you're probably not going to want to work remotely, but you don't have to work remotely.
Gotcha.
It's really up to you. There are bioinformaticians that go to the office every day.
Okay. So you have that flexibility. Okay. All right. Here's the next question. So for the kid that's sitting here watching this, or maybe even, an adult that may be watching it and is thinking, hey, I've always been interested in coding. Maybe it's a great time for a career change, especially since we're all teleworking now anyway. Give me if you could, timeline. So I'm going to take it more so from our student standpoint. Graduate high school, they're entering college. What's the timeline like for someone that's interested in taking this path? What are the courses that they should be, focusing on now in high school and then again in college? And what's the level of degree that they need to be successful in this type of position?
So I definitely think this is an area that's easiest if you learn the coding language when you're younger. I mean, it's like any language. If you've learned it at 12, you're going to keep it for probably your whole life at some level. I learned it at 27. That works. That works fine for me. Right. But it's easier starting it earlier. But you don't have to. And so I would encourage someone in college. You don't have to take a programming course, but to at least maybe a professor that's doing biological or chemistry or whatever area you want, and they have big data sets and they're looking at doing, bioinformatics type stuff. Go in that lab, learn it hands-on. It's not as much about the theory as the application. If you have something that you're interested in analyzing, then you'll be motivated to learn the language. And there's multiple languages. I personally love R. I think it's really easy. It's
I'm sorry, you said R?
Excel, R, just the letter R.
The letter R, okay.
And the other thing is free. It works on a PC, a Mac, a Linux. So whatever you have, it will work. There's also, so R Studio is the program, kind of like how Excel works with spreadsheets.
Okay.
R Studio is the program to do R.
Okay.
But the main one, and it's free. It looks like Excel when you open it. There's just an area to write sentences, and it's really friendly. The community is great. The community is very open, non-judgmental. There's a group called R Ladies who supports, all female, non-binary, just a welcoming group, and so helpful with troubleshooting and really encouraging. And so if you're looking for that kind of community feel where you can learn, you can make mistakes, R is my favorite. Python is another big one, but you don't have to learn C++. If you're, unless you want to learn it, I mean, really just one programming language, if you know it at some level, you can do it. And you don't have to take formal coursework, but it is useful to have some sort of training. But almost all of mine was just learning by doing. I have this data set. I want to know what gene is causing this person's cancer.
Okay.
So I am motivated to find that out versus if I, was just given this example data set to analyze, that would be less interesting to me. And so it would be, I would learn probably less from that. So it doesn't have to be formal training.
So it sounds like coding is basically the foundation for this type of position, if I'm hearing correctly. So, So all of you computer people out there, all of you future and current coders, here's something that you may not have known, and here's a career that you can actually go into, and it sounds like it's a lot of fun. The other thing that I hear that I think is so interesting that I think other people in different industries maybe don't have access to, it sounds like your community and the people that you network with, it's global, first of all, because computers are global, and it seems like it's constantly changing, and that keeps that connectivity between you and your colleagues and associates that you meet from different places, because technology is always evolving. There's always some type of advancement, whether it's on the biology side or whether it's on the technology side, that allows you guys to continue to grow and learn, so that you don't become the data, like, again, it's data, it doesn't become stale and stagnant, so it's always evolving. So for the person that doesn't like the monotony of a particular job where it's the same thing day in and day out, this sounds like this would be something, especially if they're into coding, that would be ideal for them. Awesome. So here's the hard question that I know some students, because every student at some point in their life, unless they are just like that super student who doesn't mind being in school forever, they're going, hey, I can do 12 years, no problem. So for someone that's interested in this, are we talking a typical 4 years of post-secondary education, or is it the 4 years and then I heard you mention a master's versus the PhD, and that part about the PhD paying you as opposed to you paying for a master's? Great information, because I know a lot of people probably didn't do that. So what's the best route to go?
So I did not want to pay for a master's. That would have been funded with, grant. I would have had to take out loans for that. So I was not interested in that. I did work a few years as a lab tech. And so you can do that. You don't have to make this decision right after college. So I think most bioinformaticians do a master's after their college, but you don't have to. So it's most about the skills. But just if you're interested in a specific disease or area, it helps to have an extra year or two at least to really learn about that. And the more, the higher degree you get, the more freedom you get, the more job options there are. And so while it seems like doing an extra 2 years for a master's or 5 years for a PhD is such a huge time, it's usually only an extra year of classwork. And the rest of the time you're doing research and you're deciding what you research. And if you're taking classes, you're deciding what additional classes you're taking. Like I took a few extra workshops on how to code, and they were informal, and I didn't have to do that, but they were something I was interested in. So it's really only an additional year or maybe year and a half too that you're doing coursework, but it's coursework you're interested in. And in a PhD, you're getting paid. And I actually got a raise when I went from a lab tech to a PhD student. And when you're a PhD student, you still get all the benefits of being a student, but they're also paying you and you're getting paid healthcare. So I think in today's economy, that's in uncertainty, it's a really stable thing. Absolutely. To have a PhD, funding and still the flexibility to learn during that time and to set yourself up so that you have a position you want. So it's not an extra 5 years of school. It's, an extra year or two of classes and then 4 years of on-the-job training that you're getting paid for.
Okay.
And you get a degree at the end. So it's a bonus.
It's a benefit. So I'm going to ask this question because as a former teacher, there was always that one student that was thinking this. I'm a whiz when it comes to computers. I've been doing coding since I was 6. I know how to do this stuff. I don't need to go to college. I can do this stuff because it comes natural to me. Do you have to have a 4-year degree to be a bioinformatician? Yeah.
So you don't have to. So data analysis is kind of the general coding field. And for data analysis, I think it's more acceptable to get a job without a 4-year degree. In biology, it's usually considered that you need some sort of additional education. I mean, there's just so many concepts in a lot of these areas. And if you really want to, dive down into like DNA, you have to have a little bit more of training. And, do you need a 4-year degree? No. Is it going to be really hard to find a job? I think so, because, for better or worse, a 4-year degree is, kind of the standard. And so if you want to set yourself up, for a career that you have control over and getting, paid, a livable salary, right. I think it's really the best decision. You don't need to go to a fancy college. I went to a state school, but take advantage of what resources you have. If you're at a small state school, go to the genetics professor or go to the biochemistry professor or physics or whatever you're interested in and just say, hey, can I come and do some experiments in your lab? And that's a great place to do it because especially at a small college or, small public university, the teachers there are really nurturing, and more, I think, more patient with you failing at experiments. I failed at every single experiment I did in my undergrad professor's lab, but that's where you get that nurturing and where you get to decide, do I want to do this? Do I want to invest my life in this career? Because the worst thing you can do is decide, I don't want to, do any additional classes, so I'm just going to take the first job available. And then, 5 years later, you're starting your countdown clock to retirement. Like, that's not how it should be. You spend so much of your life working. It should be something that excites you and, brings some meaning to your life. And, there's plenty of ways to do that.
Agreed. Well, we're getting close to the end of our time. And so in our last few minutes, I do have one additional question I wanted to ask you. So to the student that's sitting there and they're going, okay, this has been like really informative. It's been a lot of information. I'm trying to process it all. I think I might be interested in it, but I'm not quite sure. Are there any links or resources or websites or places that that students can go and look to learn more about coding or the different languages or anything that you could suggest that if anyone was interested in finding out more about what you do or just about coding or whatever in general that they could go and take a look at?
So there are many bioinformatics resources for learning out there, and I mean, I just kind of learned like on my own
Okay.
with my data set. So I know, there's a lot of different like, so if you're a female, I would suggest just going to to Our Ladies and seeing, just to kind of get a gist of what the R community is like, or males too. Anyone is welcome
And again, that was the R with the letter R, correct?
yeah.
Okay.
But I will follow up with specific emails and resources or resources and websites, because there's just so many. There's almost all of the bioinformatics have free online books, and so that is really good. One thing with bioinformatics is you spend most of your time Googling, because that's much quicker than trying to write code yourself. Is just to say, I want to do this thing, and then you Google it and you get an answer. But when you Google, obviously the words you use impact the results you get. And so just reading, an introductory chapter on a language is really useful to just understand, okay, this thing is called a variable. And so when I say, I want to look for this thing, instead of just saying this thing, you could say variable.
Right.
And, so it's just those little semantics. But there's so many resources that I think it would be best if I just wrote them in a list. And of course,
and we can always,
anyone interested, feel free to reach out to me, because we need coders. I need people to come, and I need computational people to write programs that I don't have to do it. And I need bioinformaticians to come, because we're getting data. Everyone is getting more and more data, and we need people to join us and try to mine this data.
Absolutely. And with this pandemic that's going on right now, I'm sure that there's a lot of research and data that's coming in that's going to impact us forever, really, because this is unseen, and at least in our lifetime. So I know that there's been a lot of things that have been going on that are impacted, and I'm sure that you and your colleagues and your entire community is probably going to be flooded with work and things to do. So you heard it right from Alexis, guys. She needs help. So if you're interested in anything that she has said today, or finding out more about bioinformatics, please make sure that you follow some of the links that you've seen posted in our chat, and check out some of the information that she's already provided. And as she said, once we get information from her in a list, we'll make that available to you all today. So we've kind of come to the end of our time. I kind of am bummed, because this has been so enlightening. Like when I saw your title, I was like, I couldn't pronounce it, didn't know what it was. And it's been so eye-opening, because I had no idea, and it was so different from what I thought it was. So thank you so much for sharing your day with us and your time, and just enlightening me and all of the people that have been viewing. I know that everyone has enjoyed it. So I thank you so much for joining us again and taking time out of your day to sit and talk with us. And to all of you that are watching, thank you so much for joining us. As you know, you can always find out more about MBRT and what we do by following us on Facebook, Instagram, or Twitter, or finding out more about us by going to www.marylandbusinessroundtableforeducation.org. I think it's just mbrt.org, and you can find out all about what we do. So for Workforce Wednesday, for Alexis and myself, Annalisa Sawyers, we are signing off. Thanks again for joining us. Take care, everyone.
Thanks, everyone.